Hello everyone, my name is Fredrick Williams, and today I'm going to be giving my job interview presentation. I will be answering the 10 basic networking fundamentals questions and demonstrate what I've learned so far in this course. The first question is, the United States Cyber Command uses state-of-the-art technology. However, the fundamentals are as important as any innovative technology. Given that, what are the three basic local area network topologies called? The three basic LAN topologies are bus, star, and ring topologies. Each topology describes how devices are physically and logically connected. Bus topologies are simple and inexpensive. Star topologies are efficient and easy to manage. Ring topologies are stable but can be disrupted by a single failure. The next question is, the national mission teams operate on all types of networks. To defend a network, you must first understand the network design on which you are operating. Provide a brief description of each of the following network topologies and include at least two characteristics of each topology. The answer is, for a bus topology, devices share one main cable to send and receive data. It's low cost and easy to set up, but one cable failure will stop all communication. Star topology, each device connects to a central hub or switch. This is easy to add or remove devices, but if the hub fails, the whole network will go down. With ring topology, the devices are connected in a circle, like a ring, and data moves one direction around the loop. It handles steady traffic well, but if one breaks, the whole network will break. With mesh topology, the devices connect to many other devices. It's reliable with multiple paths, but it's expensive and can be very difficult to install. And with a hybrid topology, this will combine two or more topologies like a star and a bus. And this is flexible and scalable, but it's harder to manage. The next question is, our employees must have a theoretical and applicable understanding of how networking works. In the left column, each layer of the OSI model with the bottom layer at the bottom. In the right column, provide the name of the corresponding layer number. So number 1 is physical, number 2 is data link, number 3 is network, number 4 is transport, number 5 is session, number 6 is presentation, number 7 is application. The OSI model helps organize network functions into 7 different layers. Each layer has a specific role, from moving signals onto the cable to delivering user services like websites and email. The next question is to briefly describe each function of the OSI model layer using the same order as in the previous slide. Provide the layer name in the left column. In the right column, provide one function of the layer and at least two characteristics of the layer. Include the protocol data unit used by the OSI layers that have PDUs. So with physical, this moves the signal through cables or wireless, defines connectors and voltages. The PDU is bits. The data link delivers data between devices on the same network using MAC addresses, handles error detection and PDU frames. The network sends data between different networks using IP addresses and routing. The PDU is packets. The transport ensures complete delivery of data using TCP or fast delivery with UDP. PDU is segments. This with session manages communication sessions between applications. The PDU is data. The presentation formats, compresses, and encrypts data for applications. PDU is data. An application provides services like email, web browsing, or file transfer, and the PDU is data. Each layer builds on the one below it. The bottom layers moves physically, while the top layers handle user interactions and applications. The next question is, the United States Cyber Command requires an internet service provider to connect to the internet. What is the point at which the operational control of ownership changes from the ISP to the United States Cyber Command? That point is called the demarcation point, or DMARC. It marks where the ISP's network ends and the Cyber Command's network begins. The ISP is responsible up to the point, and Cyber Command manages everything past it. The next question is, our teams operate and encounter all types of devices. Provide at least 2 characteristics for each of the following common network devices. For the first 3 networking devices, also include the OSI layer at which the device operates. The hub, layer 1, sends data to all connected devices. It's simple and cheap, but it's inefficient. Switch, layer 2, sends data only to the intended device. It's more secure and faster than hubs. Router, layer 3, connects different networks and forwards data between them. NIC, hardware inside a computer that connects it to a network, wired or wireless. Each device has a specific job. Switches and routers are smarter than hubs, and NICs are essential for any device to communicate on a network. The next question is, the national mission teams require implementation of protocols. Provide the port numbers that each of the following protocols use. For HTTP, it's 80. HTTPS is 443. SMTP is 25. SMTP over TLS 587. SNMP 161. DNS 53. LDAPS 636. DHCP 67 for server, 68 for client, and Telnet is 23. Port numbers let a computer know which service or application should handle the traffic. For example, web browsers use 80 for regular HTTP and 443 for secure HTTPS. The next question is, provide the IP range for each network class. The question is asking for the class range, not the private IP range for each class. Class A is 1.000 to 26.0.0.0. Class B is 128.0.0.0 to 191.255.0.0, and Class C is 192.0.0.0 to 223.255.255.0. IP classes help organize large blocks of addresses. Class A is for very large networks, Class B is for medium networks, and Class C is for smaller networks. And the next question is, for each network class, provide the default subnet mask in the default subnet mask column. Class A is 255.0.0.0, Class B is 255.255.0.0, and Class C is 255.255.255.0. Subnet masks show which part of an IP address identifies the network and which part identifies the device. The last question is, give the definition of an autonomous system. Describe the operation of interior and exterior routing protocols as they relate to an autonomous system. Your answer must not exceed 5 sentences. An autonomous system, or AS, is a group of networks that's managed by one organization under a single routing policy. Interior routing protocols, like OSPF, work inside the AS to find the best path for data. Exterior routing protocols, like BGP, connect one AS to another. Interior protocols focus on speed and efficiency within the network, while exterior protocols manage how traffic flows between different paths. Cisco 2023. Basic explanation of all that is, interior protocols keep internal networks running smoothly. Exterior protocols control how an organization network connects to other networks worldwide. So that's my presentation. Thank you all for coming, and have a good day.